I'm Suryan Sharma and I'll be presenting our work Hermes Wind Energy Harvesting Wireless System for Sensing Angle of Attack and Wind Speed. And I am from Delft University of Technology, Netherlands. So let us start with asking what is angle of attack? So angle of attack is a fundamental aerodynamic parameter defined as the angle between the reference line of an airborne body and the relative wind velocity vector. Now, accurate measurement of angle of attack together with wind speed is crucial for maintaining appropriate lift and preventing stall regimes during takeoff, landing, and cruise for different airborne bodies. The sensor for these have played an instrumental role starting from the advent of the first human aircraft in 1903. Although these sensors have been integral elements of both aircraft and UAVs since almost a century, even today they are prone to inaccuracies and faulty measurements. Which leads us to the problem of designing a sensor for reliable measurement of both angle of attack and wind speed. Now, this is non trivial. There are a series of research goals and design challenges which we enumerate here. In a nutshell, reliability and form factor are two very important criteria to keep in mind when going about such a task. Now, literature provides a few works that have addressed some of these challenges, however, they all fall short. These severe limitations in the state of the art inspire us to come up with a novel sensor design. The question we address in this work then is, can we design a reliable small size sensor that can independently measure angle of attack and wind speed and thus increase safety of flights? And in the words of Barack Obama, yes, we can. We present our sensor Hermes, a novel wind energy harvesting piezoelectric based wireless sensor which can reliably and simultaneously measure AOA and wind speed. Named after the Greek god of travelers and not the brand of purses, Hermes is first of its kind. It leverages as a source of energy the very physical phenomena that it is designed to measure wind. Hermes employs piezoelectric films to utilize aerodynamic flutter, which is introduced by wind, to sense and harvest energy while being completely self powered. These are the contributions that we present. We provide the necessary background on the working principle of wind induced piezoelectric film flutter, and we describe the complete system and design principles. We also built a 3D printed Hermes sensor unit complete with mounting and electronics, and we provide an empirical model of AOA and wind speed sensing through piezoelectric voltage characterization. We also propose a computationally inexpensive real-time algorithm called NSR or nonlinear surface regression for the simultaneous and accurate estimation of these two quantities. And in the end, we provide extensive performance evaluation of Hermes. This figure shows the comparison between actual and estimated value of alpha and u. Although it is hard to track extremely minor variation in wind speed, which in reality is unnecessary, averaging provides considerable accuracy. On the other hand, it can be seen that the accuracy of alpha is significant, substantiating the high performance of Hermes. With the estimation error of wind speed is below zero point 0.2 meters per second with 90% probability, the error of alpha is within 1.2 degrees with 90% probability and within 2 degrees with 95% probability. For the chosen averaging interval and the parameters of the algorithm, the sensing rate is fixed at 2 Hz. This figure shows the energy harvested by Hermes over the entire range of alpha. It can be seen that Hermes can harvest at least 377 microwatts and a mean of 440 microwatts over the entire range of alpha. This power is sufficient for transmitting the sensed value at 2 Hz at low power, this is 0 dBm and lower, and at 1 Hz for max power, which is at 6 dBm, which is more than sufficient for most applications. In conclusion, by designing and testing Hermes, we took a step towards a journey which harnesses the power of technology and research to benefit commercial aircraft, UAVs, and fixed wing drones. Our novel sensor and algorithm, powered by wind induced flutter, attempts to bring us closer to increased reliability for all airborne vehicles. Hermes, with its self powered independent nature and accurate wind speed and AOA measurements, opens up a new avenue for wireless avionics sensors. This is the first time a phenomena like flutter is being leveraged, and this is a new and exciting field for everybody. We hope that we could tell you about our work sufficiently. Thank you.